Hello everyone, let's talk about the hardest problem of contest 300, weekly 380. This problem is a variation of the second problem of the contest. This is the second problem, and the constraints are different. So for the second problem, A length and B length are less than 10. So finding an occurrence of A in S was easy. You can just do a for loop. But for this problem, which is the hard problem, A length and B lengths are 500,000. And that is very big. You cannot just do a for loop on S and see if you can find A and find all of the occurrences of A. But this is kind of a classic problem, finding all the occurrences of one string in another. And there are a few solutions. I'm gonna discuss in details one of them and mention the other one, and you can tell me about other solutions that comes to your mind. The one that I'm going to discuss is includes hashing. So I'm going to discuss it in details. How do we solve this problem with hashing and two pointers? So let's read the problem just for the sake of reading this problem. You're given a string S, a string A, and string B, an integer k. An index I is beautiful if basically Si, the substring starting at I equals to A. And also there exists another J index that the substring starting at J equals to B, and the absolute difference of I and J is less than or equal to K. So this part of the problem is exactly this part of the solution is exactly as problem 2. So we need to find all of the occurrences of A in S and all of the occurrences of B in S, and then we will decide which indices are beautiful and we will add them to the result. So we need to find all of the occurrences of A in S and have them in one vector. So one vector will have all of the indices 1, 7, 9, 12, 20, 30, something like that. This is all of the occurrences of A, and this is all of the occurrences of B. Let's say 3, I don't know, 10, 15, and 25, and 60, something like that. And this is all of the occurrences of B. So if we can find these two lists, then solving this problem would be easy. We can just solve it with two pointers, which we did for problem 2. So the two pointer part of the solution doesn't change. The part that changes is generating this list for A and B, which is not easy anymore. We cannot do a for loop. So let's see how we can do that. For that, we are gonna use hashing. Example, so let's say S equals A, B, A, and C, A, B, A, B, A. And A is A, B, A. So one way of finding the occurrences of A in S is to have a sliding window of S and compare that to A every time. So if we have this and we compare it to A, is it equal? Yes. So we add this index to the output. Then we roll this one over this window and we see BAC. Is this equal to ABA? No, it's not. So we move on. ACA. Is this equal to ABA? No, it's not. So the part that I say is this window equal to A? So in problem 2, we used a for loop to find the answer to this. So for this, we used a for loop. But a for loop is costly, and it takes us O of n. If n is length of a, it takes of O of n to figure out whether this window is equal to a. But what if there is a faster way? Can we do it in O of 1? Can we do it in O of 1 and say, hey, is this window equal to a? Yes, we can, if we represent each string with a number. If we represent each string with a number, then we can easily compare the two numbers and see if they are equal. How? Let's see how. So how can we represent a number, a string with one number? We can present that string in base p, which p is a prime number. It could be, for example, it could be 97. It could be any prime number. How do we do that? If we present a in base p, it's going to become a p2 plus bp plus a, right? So a p2, bp, and a p0, which is 1. Okay, so this is the number. This number now represents a. So if we create a sliding window here and generate ABA, so this is going to be AP2 plus BP plus A. So these two numbers are equal. So the comparison is going to take O of 1 now. But how do we update this number, which we are going to call current hash? I'm going to call this current hash. How do we update this? So first we should get rid of, so if we want to update this, that means our window is going to become BAC, right? So we should get rid of A. So we get rid of A. So if this is current hash, so hash minus equal, we know this letter, so A to the power of P2. So now hash is BP plus A, right? Now we should multiply this by P because we are moving B and A one letter to the left in base P. So this should become hash times P. And now hash is BP2 plus AP, right? Now we added C to hash. So hash plus equal C. So now hash is BP2 plus AP plus C. So in constant time, this is constant time. So we got rid of the first letter, we multiplied by a number, and then we added some number to hash. This is constant time, O of 1. In constant time, we could update the hash that represents our current window. This is great. And now we can just compare these two. So we compare BP2 AP plus C to this number. Are they equal? No, they are not. So we move on, one letter at a time. And we just need to do these 3 operations to find the next hash. The only thing is that in order to prevent overflow, each time we do multiply or we subtract or we add something, we are gonna do it mod some number. We are going to keep the arithmetic operation, and we are going to retain, we're going to keep the modulus. I'm going to discuss that when we are writing the code in more details. So that's it. That's it. We can just use this hash algorithm to find these two lists, and then we can use the 2 pointers. Let's go and see how we can write the code. So 2 lists, I'm going to define them. Now let me go first and define this function. So first I need to find the hash value of A. So then I'm going to do the same thing for S, starting at 0. Now, if these two are equal, I'm going to add 0 to the returning vector. So I'm going to define a vector. Okay, now I need to define get hash before. Okay, now I need to iterate over each letter of A. And each time hash is going to be multiplied by P, and then the last letter will be added to hash. So I will multiply hash by prime and then add the last letter to it. So try this, pause the video and try this for ABC and see what happens. So first we are going to add A, and then we are going to multiply A by prime, and then we are going to add B, and then we are going to add C. And we are going to do this. That's it. So if you give ABC to this function, it will return to you A times prime to the 2 plus B times prime plus C. Pause the video and check why. Let's go back here. So now we should start rolling the sliding window. So we have this. Now we should remove this letter and add the next letter. So we need a for loop that starts here. So this is a.size. This is 3. 0, 1, 2, 3. So for int so what is the previous index that should be removed? It's I minus a.size. It's I minus a.size. So 3 minus 3 is 0. Now I need to change the current hash and do these 3 operations. So minus A times P2. So I have A. So that is now I need to have these P2, P3, P1, all of the powers of P, but I should keep the modulus of each power. So I need to pre-calculate this. So let's go and pre-calculate it. So this power, I'm gonna fill it here. So power I. That's it. So we just fill power, but we keep the modulus each time. Now that we have the power, we should just start doing this. Hash minus equal a times p2. A is previous letter. So instead of sprev, we are going to keep the actual value, which is minus a plus 1. So minus a plus 1. So in this way, a is going to become 1, b is going to become 2, and z is going to become 26. So this is why we do this. You can do this in your programming language of choice so that you have these values. So current hash equals current hash minus prev letter times power a dot size minus 1. This is power a dot size minus 1. As I said, if the length is 3, p is going to be 2. Okay, and then we do mod here and also a mod here. The next step is we should multiply it by p. So current hash equals current hash times p prime. And the last step is we add the current letter. So current hash equals current hash plus si minus a plus 1. Mod. Okay. So now we have it. We have it. If current hash is equal to a hash, we are going to add I. We're going to add not I, previous plus 1. So this is previous, and current hash is previous plus 1. So result dot push back prev plus 1. That's it. And then we return result. So before moving on, let's test this function and see if this works. So we have called this, yeah. So vector let's just return this so we can test this. For auto x a list and do the same for b and run. Let me put this out. Prime, sorry. Okay. This is 1,000,000,007, which is a prime number. Okay, we have nothing in the std out. Let's go and see what the problem is. Okay, sorry, the problem is get hash. So here I'm iterating over all letters of A, but I need to consider a start and end. So int I 0 start, I less than or end, I plus plus, char c equals a I. Okay, we have, let me get rid of this. And also let me get rid of this. Okay, now you see this works. 1633 are the occurrences of A, and 4 and 18 are the occurrences of a squirrel, B. So now I think our find indices work. Let's go ahead and work on the 2 pointer. Okay, now we need to check if I and j are close enough. If this is the case, I'm going to add I to the result. And I'm going to move I forward. Else, whichever is smaller, I'm going to move that forward. Okay, that's it. So let's see if this works. Zero and one. Oh, sorry, not I and j, but a list of I. Okay, this works. Let's submit. Good. Now let me tell you about one variation of this problem. So here is the variation. You are given a zero index string s. This is as the problem statement. You are given a, you are given b, but you're not given k. Instead, you are given the size of the beautiful set. The size, not the actual indexes. So now we are looking for the minimum k that holds true for the given s, a, b, and t. So for example, in this example, you're given s, you're given a, you're given b, and you're given 2, not 16 and 33. You're given 2. And you should return 15 because 15 is the smallest k, I think in this case, that you will have the beautiful set size of 2. or in this case, you will be given S, you will be given letter A, you will be given letter B, and in this case, K is 0. The size is 1. The minimum K is 0. You don't need K4. K0 is enough because A and B, both of them are here, and that is enough. So let me know what you think about this variation, and if you have any questions. Thank you.